A growing number of scientists warn that humanity may soon face a satellite apocalypse. This term is not used to describe a sudden collision or a dramatic science fiction event. Instead, it refers to a slow and largely invisible crisis that threatens astronomy, the night sky, and our long-term ability to study the universe. The danger arises from the explosive growth of artificial satellites that orbit the Earth, many of which belong to large constellations intended to deliver global internet access. The scale of the increase is unprecedented in the history of space activity. In 2019, there were only about 2,000 active satellites in orbit. Today, there are roughly 15,000. If all current applications for launches are fulfilled, the total number may reach about 560,000 by the late 2030s. This estimate includes the expanding Starlink network and several ambitious competitors that plan to deploy tens of thousands of spacecraft. Starlink and similar systems already account for nearly 70% of new launches. Such a surge has dramatic consequences for astronomy. Researchers used advanced models to simulate how future constellations will affect upcoming space telescopes. The results are alarming. New scientific missions such as Spherix, Arrakis, and the Chinese telescope Xuntian may lose up to 96% of their images because of bright satellite trails that cut across the field of view. Even the famous Hubble Space Telescope may lose about 1/3 of its exposures as streaks of reflected sunlight contaminate observations. Only instruments located far from Earth, such as the James Webb Space Telescope and spacecraft near the second Lagrange point, remain mostly safe, although they too may experience some interference. The core of the problem is brightness. Many satellites now reflect sunlight with an intensity comparable to the brightest stars in the night sky. Planned future models are even more reflective. Some designs may include surfaces with an area close to 3,000 square meters. These giant structures could outshine Venus and Jupiter, becoming among the brightest objects visible from Earth. For astronomers, this is a disaster. Telescopes are sensitive to faint light from distant galaxies, but a single bright satellite trail can corrupt an entire exposure. The study shows that the problem is not simply cosmetic. It threatens key scientific goals. Contaminated images can undermine surveys that search for dark energy, observe early galaxies, or study the chemical composition of stars. Entire missions may become less effective or require far more time and resources to produce reliable results. The economic and scientific losses could be significant. Some mitigation is possible. If satellite operators provide precise information about the position and movement of their spacecraft, astronomers can predict when trails will cross a telescope field of view and correct their data more effectively. Adjustments to satellite orientation or changes to the reflectivity of their surfaces can also reduce the amount of sunlight they scatter. But these measures are only partial solutions. They do not fully address the fundamental issue of overpopulation in orbit. The authors of the recent research argue that the world urgently needs coordinated international policies. These may include lowering operational orbits, reducing the brightness of satellite surfaces, and rapidly removing spacecraft at the end of their mission. Without such global agreements, Earth orbit will continue to fill with reflective objects at a pace that threatens the future of observational astronomy. If action is not taken soon, by the year 2040, humanity may look up at a sky where natural starlight is increasingly drowned out by artificial objects. The satellite apocalypse would not be a single dramatic event, but the gradual loss of an unobstructed view of the universe.